Okay, so we can write I equal to 0 to n, okay, f of x I plus delta x minus I equal to 0 to n f of xi. And f of I plus delta xi can be written as f of xi plus 1, okay, minus I equal to 0 to n f of xi. Why it is written like this? So if this is the xi and this is the xi plus delta xi, so that's definitely, this difference is delta x, so that's definitely x plus I plus 1, okay. So if this is the, let's say, x2, then that must be x2 plus delta x, which is exactly equal to x3, okay. Now okay, so how we will write this? So this can be written as f of I will, if I equal to 0, then f is x1 plus f of x2 and the other term, okay. And finally we're gonna have this f of I think this okay, yeah, one thing that I have to mention over here, because this term is one more than the I, so finally this, okay, so this f of xi plus delta x should be this term, okay. If we are taking these two lines, then that f of xi plus delta x should be this term. If we are at the edge of this curve, then that this curve is f of xi plus delta x. So how what it is going to be equal to? This is going to be f of xi plus 1, and this is the edge, okay. Beyond that we cannot go. So this x of I plus 1 should be x of I plus 1 at this location should be your x of n. So I plus 1 should be equal to n. So in the same way, I must be n minus 1 at the last location. So but I've done a mistake over here. Instead of I goes to 1 to n, we should go, I should go from I should go 0 to n minus 1, okay, because I x of n plus 1, because this is I plus 1, so if it would be the n, then that last term would give x of x f of x n plus 1, and n plus 1 term, we don't have this x of n plus 1 term. So in the last we will get this I plus 1, and n minus 1 will give I minus 1 will give f of xn, okay. And okay, right, in the similar minus term, we're gonna have this minus term, right, and we're gonna have this f of x of 0, and again we have the x minus n plus f of x1 plus f of x n minus 1. So we can see that these terms will cancel out, okay. These terms will cancel out over here, and only thing that we are left with, this n minus 1 will also cancel out, because before this, just before this f of x n, there will term the f of x n minus 1, okay. So these terms gonna cancel out. We are only left with this f of x0 and f of xn minus f of x0, and f of xn is nothing but b, and f of x0 is nothing but a, okay. So we will left with this f of x b minus f of x a. Okay, right. Now all this thing works like this. Now if we take the limit delta x tends to 0, okay, then that the summation will become an integration. Okay, if we take the limit in this, we'll get the integration, and this del term will become the differentiation, right? So we have proved it. Okay, so we have finally proved this, right? So what this means, that if we know the derivative of a scalar field f, so taking the derivative of a scalar field f and taking the integration over the variable x will give the value of that vector field at the two upper and lower limit from where the integration starts and integration ends.